Hi, everybody. These are our directions for temperature and heat. And I'm going to give you the answer to question one right off the bat. So you should be ready to type as I say this. But question one are what are the two main ideas regarding temperature that we've found out so far? So we've been talking a lot about temperature. We know that the lowest possible temperature that you can have is absolute zero. We know that any things in the environment love to be the same temperature. We found that out in room temperature. And those are two offshoots of our two real main things. The two main things that we've talked about with temperature really are that temperature is a measure of how fast particles are going. And absolute zero is absolute zero because that's the slowest possible speed of particles, which would be no speed at all. But a big idea on temperature is that it is a measure of the speed of particles. The other big idea on temperature is that anytime you have two things that are at different temperatures, the hotter temperature is going to travel to the colder temperature because they don't want to be different. And it's like a one-way highway. So let's summarize for question number one. The two main ideas regarding temperature that we've found so far is temperature is a measure of speed of particles only, and that higher temperatures always want to flow to lower temperatures until there's no temperature difference. Okay? Now, so write that in for question number one. On question number two, you're going to be using the sim actually through the rest of this, and each thing is going to take you through the sim and tell you exactly what you need to do. Now, I'm going to go ahead and model this first one. So you're going to want to get the sim going. Once again, we'll go to the thermal energy sim, and we'll pull this up. I'm going to bounce between the two of them here. And this one says that you want to find the mixed temperature, and there's two things you're going to have to run this twice. Can't do it all at one time. So our large sample is going to be one of our things. It's going to be at 25 Celsius. So we're going to add a large sample, and we don't have to change the temperature at all because they come in at 25 Celsius. And then we're going to go ahead and get a small sample to mix with it that is 65.9 degrees. So we're going to come back here. We'll do now a small sample, and we'll move it to 65.9 degrees, and that's one of the preset ones, okay? Now you're set up. You can mix them, and then you can go ahead and put in their mixed temperatures. You want to leave them mixed until the temperatures equalize and they become kind of a room temperature so that they're both the same temperature. And then you'll just do that same thing down here. You'll get those, and then you'll answer question three based on that. Question four, you're going to want to do with a new one, and I'm not going to say too much more because I don't want to give it away, but you're going to want to show with the new table, and in this table, you're going to want to prove it by writing in some mixed temperatures, and you see that X right there? You're going to want a number in place of the X. You will choose it. That will answer question four. Okay? Then in question five, once again, you're going to mix some of these, mix this first one again. It just spells out exactly what it is, but you're going to do something with it a little bit different. Read that and it will see. And then this one will ask you if what you wrote in five is always true, and we'll want you to mix some other samples. You kind of got to read through them to do them, and I don't want to say too much more because I don't want to give them away. Okay, so this is trickier. Heat is trickier than temperature, and one of the things we want to find out today is why that is. Why is heat more difficult than temperature? Okay, and that's it. Good luck.